I'm Scott Moore, and I'm a performance engineer. I help to make software and applications faster, better, more resilient. Lately, there's one thing on my mind.
Where's the best barbecue at, man?
So I'm going across the country, talking about performance engineering and barbecue. Join me as we take the performance tour. This is to see if James Pulley can actually think and drive at the exact same time. I'm concerned, I don't know about you, we talk a lot now about shifting left. You can't talk about shifting left and stay in the realm of performance testing. You have to begin changing the conversation to talking about performance engineering. And performance engineering entails many different disciplines: capacity planning, working with development. That's the whole part of shifting left, and you need roles that can get outside of just performance testing in QA in a specific environment, and they need to be able to go over the entire life cycle. So there's a slide that James and I present many times where we've got all the different disciplines that make up performance engineering. So James, why don't you talk a little bit about some of those elements of performance engineering? What if you had to try to put all the different pieces in place? Performance testing is just one small piece of that, right?
It is, and realistically, anytime you ask a question that involves time and resources, you're engaging in some sort of performance engineering exercise. So, and we do that very effectively for multiple users inside of performance testing. But you can back that out towards the beginning of the process or carry it through the rest of the life cycle. If we were to back it towards the beginning, you can ask a question for a single user on time and resources. You can back this into development and ask a question on time and resources. You can even back it all the way up to project inception, where you are making statements about time and resources. So when you carry it forward into production, you now have questions of time and resources with RUM and system monitoring and things of that nature. Projecting that forward over time, you now have capacity planning, and carrying that forward just a little bit more, you have interface simulation and modeling. So you have this kind of full life cycle view of performance. Starts with contracts at the inception, goes through development, goes through single user QA, multiple user QA, in production, and then you have the collection of those statistics over time for capacity planning, all the way back out to simulation and modeling to answer questions. Did I cover it while I was able to drive?
I think you did. He's doing pretty well, don't you think? So let's continue this conversation about shifting left and performance testing versus engineering. So let's just forget about Agile for a minute. In the traditional waterfall methodology, we could, as performance engineers, gotten earlier in the life cycle, we didn't have to stay in the testing environment, or if we were lucky, a staging environment, and then try to test performance into the product at the tail end. That's what ended up happening. It didn't have to be that way. I always advise people, okay, when you get servers in, if you know the kind of web server, for example, that you're going to have, test against that web server once it's brought up under those configuration settings. Maybe you just load an image on the screen of certain sizes. You have a page with a different size GIF image, for example, and turn off caching so that every time you make a request to that page, it hits it as hard as it can, and test the web server independently before you even have to put any of your real website on there. So now you can start getting baselines of the web server itself. You can run additional tests against, just to see how much the CPU is actually, how well it's doing. You can run certain pieces of code to see how well you're taking advantage of threading, for example. So we could have done this before, but we didn't. And the reason why we didn't, my opinion, I think, is we were lazy. We just didn't want to do it. We didn't have time to do it. There was never time to do it because we had to get it out. Enter in agile methodology. I believe we're carrying forward the same problems. We still have problems getting earlier into that life cycle for the same reason. So it's not a methodology problem. Would you agree?
I would agree. It's a structural problem. And I would say that performance not only suffers from this, but also the security profession. When you look at project inception documents, and that's under waterfall, agile, scaled agile, DevOps, Bob's process du jour, it really doesn't matter. If we don't capture what is acceptable response, what is acceptable system utilization under our expected load conditions at the beginning, we're doing ourselves a disservice, because architects no longer have the information necessary to set performance budgets. Developers are unable to ask questions which match expectations on the part of business. Functional testers are not able to ask single user performance questions. And invariably what happens is it comes to the performance group for multi-user performance testing. We go out and we recover these business requirements, maybe. Sometimes we talk to development. But invariably when we run our test and we find an issue, the assumptions that we use to make our test or build it are different from the assumptions everyone else has made in the absence of performance guidance from the beginning of the project. The hardware team has made some assumptions. The architect team has made some assumptions. The development team has made some assumptions. And when we find a defect, even if our requirements are perfect, recovered from the business, our requirements for the test will not match what has been used to build the software, and our test will be called faulty. And in some cases, they're not wrong, because the assumptions used to build their software are different than the ones we're using to test it, and they didn't have the advantage of that when they were building their software. So their software is built correct to their assumptions, but not correct perhaps to the business requirements. Our test doesn't match their requirements.
So in both cases, we weren't building the software according to the methodology, the way the methodology was intended to work. And we started hearing that way of doing things, the old way, didn't work, but we know why. We didn't work it right. And the new way of doing it, I'm finding the same problems with that as well. And it's the same adjustment that needs to be made. So I think that's the message we're trying to get, is a performance engineer would look at both of these and could work independent of methodology to get earlier in the life cycle using some of the same techniques and practices. It boils down to common sense, really. But,
and it's a question of value.
right.
If we can capture that data at project inception, where everybody has the advantage of having that data from a performance perspective. And by the way, this is where Google Rail becomes very powerful, because it represents a default set of conditions that you can simply roll into a project. That people don't have to think about, Google has made this recommendation, and then we can make variances from this tolerance from Google if we need it to be faster because we're in a highly competitive situation, or if we're a monopoly provider and we can be a little bit slower. but it gives a starting point that everybody has to adhere to. And that has enormous power, and it does allow us to deliver enormous value in performance engineering. Otherwise, we wind up very narrowly scoped, recovering performance requirements in multi-user performance tests, and no performance questions are ever asked until you get to that point, and that's really dangerous for product quality.
That's right.
Okay, after all that driving, we're in Phoenix, Arizona. What do you think we're gonna do? It's time for barbecue at BobbyQ.
What?
You don't smell it?
Yeah.
Something disagreeable about your meals?
No, we just ran over a skunk
Oh,
right there. See it?
Okay. My bad. Mr. Moore, you have something you want to share?
No, what are you talking about?
You smell it?
Yeah, it's a paper mill. We just passed a paper mill, man. It's right over there.
Okay.
James,
What?
come on, man.
Hey,
Come on.
hey, look, it's the stockyard.
Oh, sorry. Sorry I doubted you.
Oh my God, what is that?
That one you can blame on me.
Oh!
Three days in the car, ain't nothing but barbecue. Are you freaking kidding me? What did you expect?